All right, so we were just finished up sort of talking about kind of type 2 compounds. And when we do have type 2 compounds, we do need to figure out the charge. So we use the whole name of our metal. And again, that Roman numeral for the charge on the metal, and our non-metal again getting the IDE at the end of it. And it is a very common mistake that people make with type 2 compounds, that they just kind of use the Roman numeral for how many metals there are and stuff like that. So again, it is the actual positive charge that you actually have on the particular metal if you just took one by itself. So not the total charge or anything like that, but just one individual positive charge that's on that metal. Here are some type 2 sort of ions, and they're mostly, again, the transition metal is definitely where we find pretty much all of them, except for that zinc, cadmium, silver that we talked about earlier, which are type 1. And also outside the transition metal, in that area where we find lead, kind of below the periodic table, below the staircase there, the lead, the tin, which is SN, in that area, they also are really type 2 sort of metals. The additional in here again is the Roman numeral that we put in there. One sort of interesting one is mercury. Mercury is Hg 2 plus and Hg 2 plus. Actually, the one that has the most twos is mercury 1, while the one that has just the 1 2 is actually mercury 2. And that's because mercury 1 is actually a dimer of 2 mercury 1s together, which is why there's a 2 on the bottom. And it ends up being a +2 charge, even though it's really mercury 1. The way you kind of know, for example, it is sort of that mercury 1 versus 2 is that extra 2 would be on the bottom there. It kind of sticks around as opposed to this guy here, where you would have something that looks like this. So this without the 2, that would be mercury 2 oxide. This would be mercury 1 oxide. Again, that extra 2 on the bottom in a lot of cases for mercury will kind of still kind of hang around in the formula and stuff like that. There is an older way of naming type 2 metals, which we're not going to really use in this class. And most chemistry classes, you really don't use it, but they do come up occasionally throughout things, the way they name it. The older way of naming is we really don't use Roman numerals, but we use sort of the root of the name or the origin of the name. And we use really one of two endings, either ic or us, OUS. And the one that ends in IC is the one that has the larger positive charge. And the one that ends in OUS has the lower positive charge. You can feel like you feel icky and you ate too much. So that's the one with the most. And OUS has less. So, for example, iron 3 versus iron 2. Iron 3 has a larger positive charge, so that's called ferric. And this has the lower positive charge, so that's called ferrous. So that one that we saw earlier, the FeCl2, which was iron 2 chloride, could be called ferrous chloride. So again, for us, we will strictly use Roman numerals. We won't use that sort of older name, but especially with things like iron and copper, it oftentimes will pop up in some papers and books and stuff like that. So cupric or cupros for a copper. So those sometimes will sort of pop up. You'll see something like this later on if you get to 1B, you do a little bit of nomenclature that involves some of those type of guys. So as we talked about, again, type 2, we use the Roman numeral to indicate the charge. And whenever a metal's involved, it is always the most important thing to look at. So as we talked about with type 1 and type 2, it's the metal that you always want to look at. And if it's group 1, 2, or 3, or zinc, cadmium, or silver is type 1, you don't need to worry about Roman numerals, just whole name and IDE. If it's type 2, which should contain a transition metal or to the right, you do need to worry about Roman numerals. This means you need to figure out the charge on the metal, and you could do that by whatever it is bound to. You should be able to figure out what the negative charge is, work your way backwards to balance out the charge to 0, and then include the Roman numeral, also with the whole name and the IDE at the end, but just the Roman numeral in the middle. All right, so why don't you take a second here, name these guys, and also why don't you write some formulas just to make sure. Let's say we had this here. We'll go copper 2 nitride. Let's do something. Let's do chromium or bromide. All right, guys on the left here, let's do proper names. One's on the right, let's do proper formulas. Yeah. Remember, it's ionic, so the formula needs to equal 0 when you put the positive and negative guy together. CO is just cobalt, that's a metal. Cl is chlorine, which is a non-metal. So right away, I know it's ionic. I want to look at the metal part of it, which is cobalt, which you can find in the middle there, the transition metal region. So that should tell me that it is a type 2 type compound, which means I do need to figure out the charge on the cobalt. So although I may not know the charge on the cobalt, I do know that Cl is group 7, which means it has a -1 charge. And there are 3 of them, which gives us a grand total of -3 for the negative charge. That means the cobalt needs to be +3 to balance it out to 0. And that means that the name here would be full name here. So cobalt, Roman numeral 3, again for the charge. And even though we have 3 chlorides, it doesn't matter. It's just going to be chloride there at the end. So cobalt 3 chloride. Any questions on that one there? All right, take a look at the next one, which is Cu, which is copper, which again is a metal. I, which is iodine, which is a non-metal. And again, looking at the metal, which is the important one, it is again in the transition metal region. So that is a type 2 compound. So to figure out the charge, I have 1 copper, I have 1 iodine, which is group 7. So that means that the copper here does need to be +1 to balance out the -1 charge on the iodide. Again, whole name of copper, Roman numeral 1 for the positive charge on the copper, and then iodide, IDE, at the end there for our iodine. Any questions on that one there? Lastly, here we have tin, which is a metal. We have Br, which is a non-metal. Tin is not a transition metal, but it is just to the right of the transition metals, below where the staircase is. So that is that region where they also pretty much have a variable type of positive charge. So they do fall into the type 2 compounds. So we do want to figure out the charge on the tin, which is Sn. Maybe we'll go up a high so you can see it, Sn. And we do have 3 of the Brs. Each one is group 7, which means it has a -1 charge. And frankly, you could draw them all out if you like, but that does give you a -4 for the Brs. And again, to balance out the Brs, since we only have 1 of those tins, it would have to be +4 to balance it out. That means that we would end up with 10 Roman numeral 4, bless you, and bromide for that one. And once again, the 4 is the positive charge on the tin. Yeah. Any question on any of those names there? Now, if you are given a name and you need to go backwards, you need to identify what type of compound it is. Is it ionic or so? And how you should go about it. So when I see something that says copper Roman numeral 2, that tells me that the copper should have what type of charge? +2. Yes, that's basically what the 2 means, right? Nitride is nitrogen from the periodic table. Nitrogen is group 5, which means it has a -3 charge. So once again, we want to put these together to equal 0. So to do that, we need 3 of the coppers. That gives us a +6. And we need 2 of the nitrogens. That gives us a -6. So that is the simplest way to get both of those guys to 0. And that means that the formula here, I'll go up on top a little bit here, would be Cu3 N2 would be the proper formula for it. Any questions on that? Lastly, here we have chromium Roman numeral 4, which means the chromium should have a +4 charge. That again is what the Roman numeral stands for. The bromide, which is group number 7, has a -1 charge. So we basically will need more of the negative guy in this case, and we would need 4 total to get us to balance it out. So we basically need 4 of these Br minuses to give us a -4 to balance out the +4, which means that the formula here should be CrBr4 in this case. 1 chromium at +4, 4 bromines each at -1 each gives us an overall charge of 0. Question on writing the formula or given the name here? So you do need to be able to do both, obviously, for type 1 and type 2, write the formula or give the name depending on what is given to you. Any questions on that there? So just to finish up a couple of things here. As we to sort of summarize the type 1 and type 2 sort of situation, once again, type 1 is the metal. Group 1, group 2, group 3, silver. You could add to that list. Zinc and cadmium, again, do not need it because they have fixed positive charges when they do get charges. And anything that's essentially a transition metal definitely will need a Roman numeral when you do it. All right, so why don't you give these guys a go, and let's do a couple more here. Let's do magnesium oxide. Let's do iron 3. Let's do iron 3 sulfide. And let's do silver. Let's do silver phosphide. All right, so names on the left, formulas there on the right are opposite, I think, what I just did there. Okay, let's take a look. So look at the first one here. Hg is mercury, which is a metal. Oxygen is a non-metal, so that is an ionic compound. Mercury is a transition metal, so we do need to figure out the charge on it. In this case, we know this is going to be -2. So that means that the mercury here does need to be +2 to balance it out. And again, that's because oxygen is group number 6 on the periodic table, so it should have a -2 charge. That means that this is actually mercury 2 oxide. Again, this mercury 2 does not have the extra 2 on the bottom that would make it mercury 1. So again, that difference that we talked about there. Looking at the next one, that is Mg with magnesium. That's a metal. Br is a non-metal. Magnesium is group number 2, which means it's actually a type 1 compound. It has a fixed charge, so you do not need Roman numerals. So we're just going to go with the whole name there, which is magnesium. And then the bromine becomes bromide in that case. Any question on those two? Looking at the next one, which is lithium, which is a metal, oxygen, which is a non-metal. And again here, lithium, which is group 1, has a fixed charge. So that means it's type 1 type of molecule. So we'll go out this way with it. So we're just going to use the whole name here, which is lithium. And then oxygen becomes oxide in this case. Lastly, here we have chromium, which is a metal, and fluorine, which is a non-metal, so it's ionic. Chromium is a transition metal, which makes it a type 2. So in this case, we have 1 chromium, 2 fluorines. They're each group 7, which means they have a -1 charge each. That gives us a -2 overall charge. That means that the chromium here needs to be +2 to balance it out. And that would give us chromium, Roman numeral 2, and again, fluoride, regardless of how many we have. And again, the 2 for the Roman numeral there for the charge. Any questions on any of those names? Going to the right, we have the name. We want to work back. Yeah, sorry. Yeah. It is, once you figure out what the charge is on the metal, it's actually, that's what it is. Yeah. So in this case, it has a +2 charge, which means that the Roman numeral would be +2. Yeah. The Roman numeral would be 2, not +2, but it would be 2. Yeah. Sorry. Yeah. Right. So if that's your question, to figure out the positive charge, it's based on what the negative guy is it's attached to. So whatever the overall negative charge you got going on with the anion, then you need to balance it out to 0 with the positive guy. Now, in this case, we just had 1 chromium, so it will equal whatever that negative charge is. But if we had 2 chromiums, for example, and the negative charge was, say, -6, each chromium would then be +3. So you got to make sure you kind of balance it out that way. Yeah. Other questions on that? So going to the other side there, we have magnesium, which is a metal, oxide, which is a non-metal, which is oxygen, so it's ionic. I do not see a Roman numeral. That means that really magnesium should be a type 1 guy, which it is, and it's group number 2, which is +2. Oxide is oxygen, which is group 6, so that's -2. So basically, to put these together, we just need 1 of each. +2 and -2 will equal 0. So we just need a formula of MgO in this case. Yeah. Any questions on that? Coming here to iron Roman numeral 3 sulfide. The Roman numeral tells us the actual charge. That's an iron with a +3 charge. Sulfide is group number 6 on the periodic table, which means it has a -2 charge. In this case, we're putting something that is +2 and -2 and +3 together. 3 and 2, common number to figure out is just to multiply them together. That's 6. So we basically want to get everybody to 6 to equal 0. So to get iron to 6, we need 2 of these +3 guys. That will give us a +6. And to get sulfide to 6, we actually need 3 of them. Now you can just add them up. So that would give us iron with 2 and sulfide with 3. That basically says we have 2 irons each at +3, gives us a +6. We have 3 of the sulfurs each at -2, gives us a -6. So again, +6 -6 will equal 0 in that case. Any questions on that? Silver is a metal. Phosphide is phosphorus on the periodic table, which is a non-metal. Silver is a transition metal, but it's one of those that has a fixed charge. So we actually know that it is going to be +1 all the time, no matter what the situation is. Phosphide is group 5 on the periodic table, which means it is -3 in this case. Now to balance it out, we actually need a grand total of 3 of the silvers. That gives us a +3 to balance out the -3. And that means that the formula here would be Ag3P would be our formula in this particular case. So the goal of ionic compounds that we talked about is to get the positive negative charge to equal 0 in the simplest way to do so. Any questions on any of those? Yeah.